In this section, we are going to be talking about surface water movement and how water moves. Isn't that an awesome scuba place? I would love to scuba there. So, how does water move on our surface? We have something called the hydrosphere. That's what we're going to be talking about. And that's all the water that makes up the earth. So, we also have like the atmosphere and we have the biosphere, but we're specifically going to be talking about the hydrosphere or water sphere. So, all the different types of water. And we have a lot of different types of water. Most of our water, 97% of it, is tied up in the oceans, and only a tiny bit of it, 0.31, which is this is what we mostly use the groundwater, very, very, very little is in our groundwater. So here is a copy of the water cycle, which I know you already know this. The water cycle is a circle, so you could start anywhere, but we will pretend that we want to start with evaporation or transpiration. That means transpiration is the loss of water from plants, and it could be animals. And evaporation is when water just comes off of a water surface, like an ocean or a lake. You spill water outside, evaporation. It comes up here and condenses into the atmosphere, and then it will fall as precipitation. So that can be snow, it could be rain, it could be hail. And then from there, it has runoff where it basically collects in a certain place. And there it usually dissolves or infiltrates, like through filtration, goes back into the ground. But some of it will actually go back and be, water, ocean water again and go back up. So, depending on the type of surface you have, depends on how fast that water can go down into the ground. So, sometimes you have very large spaces between soil, like if you have a very rocky soil and a lot of water can just get sucked into it really fast. Sometimes there's tiny little spaces, and sometimes there's very, very, very small spaces because the spaces are already filled with it. So, depending on what kind of spaces are between your soil composition, is how much of it can go down. That's the rate of precipitation. So, another thing to point out that's important is that vegetation, that just means plants, vegetation can really, really help more water to get absorbed into the ground. Um, it does this because it obviously slows it down from moving along to like gutters or storm drains. The more it can go into the ground, the better. So, once we have our fires here in Southern California, usually we have some big fires and summer to fall. Once those fires have all burned out, they burn up a bunch of our vegetation. And then the rains, if we get it, which is good, will come. And that can cause a lot of mudslides because the water can't absorb or absorbs a lot slower without the plants. So it's actually this kind of negative cycle of losing our plants. And needing to get that water. So, streams basically, it's really important to know that streams carve the land by carrying small, like pebbles or sand, downward. And during that process, the sand and sediment will kind of scrape along the bottom, and sometimes it will actually cause something called a pothole in a stream. So here's some here where different things have eroded away the ground. And sometimes you step in a stream or something and you can actually feel that, whoa, all of a sudden there was a big hole. That is from erosion from the stream. Um, so streams carry materials three different ways, and their names are all right here. So I want you to look at those. The first one is as a suspension. A suspension is just that it's suspending something up like silt or clay or sand. So it's something that's floating along in the water. It would eventually sink if the water slowed down, but for now it's light enough that it's being pulled along. The next one that you need to know is bed load. Bed load is like large rocks or debris at the bottom of a stream that's getting rolled along the bottom. It can't float. It's just like moving along the bottom. And the last one is a solution. A solution is very tiny things like minerals that actually dissolve in the water. So it's actually dissolved. You can't see it. They're dissolved into the water. So if you put some salt in the stream, it would just dissolve and it would just be part of the stream. That's called a solution. It's really important. So if I had something like sand that's not going to dissolve, sand is going to be carried by suspension, bed load, or solution. Sand would be carried by suspension, okay, where it would just be floating along in the water, but potentially, but definitely not dissolved, okay? So a stream's carrying capacity is specifically the stream's ability to carry dirt, rocks, and other big things is its carrying capacity. How much stuff it is able to move because of how strong it is. The smoother the sides of the stream and the deeper the water, the faster it's going to move. So a stream that's spread out over flat land and it's shallow, it's not moving very fast at all. Something that's shaped like this, like a canal, if you've ever seen a canal, which is a man-made cement place to move water, it's moving really fast. It's moving really fast. So basically, deeper, smooth sides, the water will move faster. Okay, with floods, because you can have flooding. With floods, basically, when there has been a lot of water that has come into a space all at once, sometimes it goes over the levees. That means like the boundaries that either people have made or nature have made. So maybe it goes over the borders. And when that happens, you can have a flood. And so heavy accumulation of water, of excess water from drainage systems. Sometimes we have drains, like, even man-made drains in the streets and things. When you have too much water filling those up, it can cause downstream floods. So that's a pretty basic thing, but that is important for you guys to remember. So here is what a levee is. A levee is, you can make a levee by putting up cement. And a levee is basically a barrier to block water from coming out of a certain place. But levees are actually naturally formed as well. As a little stream comes down, when it gets bigger, it'll fill up a space during a heavy rain and it'll carry a bunch of extra sand and deposits that will form these little like ripples off to the side. And we used to, in the desert or something, we used to call these the whoops or whoop-de-doos or whatever. And basically it makes these little ripples off to the side. And those are natural levees. Why would anybody live near a place that could potentially flood like this, like live in a floodplain like this? They would do it because if you go back to these solutions, there's a lot of solutions and suspensions, meaning there's dirt and there's a lot of dissolved minerals that end up in this soil. So this soil ends up being incredibly fertile and great for growing foods and crops. So people over time for thousands of years have like wanted to go and move towards floodplains, not only because they have quick access to water, but it's very, very fertile in those areas. So that's all we're going to talk about in this section, and we will join you for the next.